We're going to be looking at geometric series today. In fact, we're going to be looking at the infinite geometric series. That means that we're not going to have an end term that we stop adding to. So previously we had done a finite geometric series, which means that it had a start and an end term that we added together. And so this time we're going to keep on adding, and that is only possible to arrive at a certain number if our common ratio for that geometric series is less than or equal to the absolute value of 1. So either it's less than 1 or it's greater than -1, but only in between those two numbers. So these top 3 objectives we've already accomplished. We'll be focusing here in infinite geometric series. And then after that, I'm going to show you summation notation. Summation notation. And that's just a different way of writing that we want to sum. This is an example of a problem that we will be able to solve at the end of this lesson. A ball is dropped from a height of 50 feet. It rebounds 4/5 of its height, so this is like my common ratio, and it continues this pattern until it stops. How far does the ball travel? So they mean, travel distance. Down, up, down, up, down, up. What is that total distance? So we'll get to that later. Now, there's a huge difference between a finite sum and an infinite sum. So for instance, if we're talking about an arithmetic sequence, remember that's where we're adding the same number. Like for instance, this one's, they're adding 3 every time. We cannot get a sum because it just keeps on increasing and increasing and increasing. A finite arithmetic sequence, we already did that the other day, and we use that formula as a shortcut so that we don't have to add each individual number together. A finite geometric series we did also, and that's where we have a start and a beginning, and there's a shortcut for that too. It's that formula, and don't worry about memorizing it. We just have to know how to use it, like what does A1 mean, what does R mean, etc. So today we're going to do infinite geometric series. Now, this one that's increasing by doubling, so means it's multiplying by 2, so therefore my R value is 2. Now, that's an R value that's greater than 1, so that means there is no definite sum. If I keep adding until forever or to an infinite amount of terms, there's no certain term that this is going to. However, if I have an infinite sum for my R value, for instance, this is multiplying by 1/3, is in between -1 and 1, then since we're adding a smaller and smaller amount every time, it's not really contributing that much, so we can take it all the way out into infinity, and it does arrive at a certain number. So we can obtain that certain number through this formula: sum equals A1, that's our first term, all divided by 1 minus R, our common ratio. So when we're given a problem, we're going to have to follow a procedure. So first we're going to have to identify that this is an infinite geometric sum. And in the problem, they will tell us that. So we'll be looking for that phrase, find the sum of the infinite geometric series, or something like that. Okay, but they're going to tell us, and that's going to tell us to go to our formula sheet. If you go to your formula sheet, it says these words: infinite geometric sum or infinite geometric series, and that formula is S equals A1 over 1 minus R. Okay, so there's really only two numbers that we're going to have to substitute in here. Those are A1 and R. So that brings us to our next step that we have to do. We have to identify A1. Okay, and how do we find that? Well, it's just the first number in the pattern. Okay, so typically they will give us the pattern of numbers, so we just circle the first one and plug that in for A1. Now, if they gave me a formula for finding the number of patterns, then I would just plug in 1 for n, and I could calculate what the first value is. So my second step here is to identify R. That's our common ratio. And we get that by just taking our second term and dividing by our first term. Okay, and that will give us what R is equal to. You might have to leave it in fraction form if it's ugly, okay? But we can do it. And then our last step is to substitute our values, our A1, our R, into the sum formula. Okay, I highly recommend when we're putting this into our calculator, I highly recommend using that fancy fraction, the alpha y equals. Okay, otherwise the calculator may not know that this 1 minus r is all in the denominator, so you might, if you're not using the fancy fraction, you might have to put parentheses around that denominator. That way the calculator knows that both of those things are doing the dividing. So that brings us to the I do. Find the sum if possible. That means I'm going to have to check and see is R in between -1 and +1. Okay, so I'm going to have to check on that. Okay. And then also, if it is, then I'm going to be able to use my formula S equals A1 over 1 minus R. Now, this particular one doesn't say a geometric series, but normally it will. Now, I can see that it's geometric because they're not adding on the same amount every time, so it's not arithmetic. It appears that they're dividing by 2 every single time. See how this is halving? For each sequential number in the pattern. So first I'm going to find the R because they said if possible. So if it's not possible, then I can just quit. So R, that's my second term divided by my first term. So that would be 1/2 divided by 1. Well, anything divided by 1 is just itself. So here my R is 1/2. Now if you're not good at fractions or there's multiple fractions, just stick it in your calculator and be done with it. So here's my R value. I got that. That's R. Okay, now I need to find my A1. Well, that's just my first term, so there's my A1 right there. So it is possible. Okay, because of this, our R value is less than 1. And now we're going to start substituting inside our formula. So the sum, the infinite sum, is equal to 1, which is my A1, over 1 minus R, which is 1/2. Now I can just put this all into the calculator. I would use the fancy fraction. If I were not using the fancy fraction, then I would put parentheses around the denominator so that the calculator knows that that entire denominator is doing the dividing. Okay, if not, I can also do this by hand. 1 divided by, and then 1 minus 1/2 is just 1/2, and I'm going to, instead of divide, I'm going to multiply by the reciprocal. Okay, because it's easier. So I get 2. So that is my answer. The infinite sum goes to 2. As I keep adding numbers on here and here, we eventually get to the number 2. I'm going to treat this like another I do. Find the sum if possible. Okay, so here I need to check, is r less than or equal to 1? So I'm going to go ahead and do that first, because if it's not possible, then I don't have to find a sum, because we can't. So r, that is the second term divided by the first term. So my second term is 8. And my first term is 2 square root 2. Okay, now I could just throw this in the calculator, but because I can't pull up the calculator and show you on this program, I'm going to just go ahead and reduce this. So 2 goes into 8 4 times. So I get 4 over square root 2. And when I actually put that into the calculator, I find out that this is actually greater than 1. So here, there's no sum. So no infinite sum possible. Okay, done. Let's treat this you do like a we do. So if you're watching this video, take a second, pause the video, attempt it yourself, and then after you think you have the answer, press play and watch the video. Now I'm going to start solving. Okay, we want to find the sum here. That means, and if possible. So if it's possible, I'm going to get to use that sum formula. Sum equals a1 over 1 minus r. Okay, now I need to know, is it possible? So I need to find out, is r less than or equal to the absolute value of 1? So let's calculate that. Our common ratio, remember, ratio means I need to make a fraction. That's my second term divided by my first, so I've got 1/3 divided by 2/3. Now you can totally just stick this in the calculator. Since I can't bring up my calculator, I'm just going to go ahead and use a trick. When I have a fraction divided by a fraction, instead of doing this division here, I'm going to change it to multiplication and multiply by the reciprocal. So I'm going to flip that second fraction around and then multiply the tops, put it on the top, multiply the bottoms, put it on the bottom. So 3/4, that's like 0.75. So my r value is in between -1 and 1. So we do have a sum possible here. So I'm going to proceed with this problem. I need to find my a1. That's right here. So those two things, with those two things, I can find the sum. So I'm going to go ahead and substitute into my formula now. My sum is equal to a1, which is 2/3, divided by 1 minus r, and r is 3/4. Now if I could pull up my calculator, I would, and I would just plug this in. But since I can't do that, I'm just going to do this by hand. So I'm just working on this denominator here. That would give me 1/4, and then instead of division, I'm going to multiply by the reciprocal, and that would give me 8/3 for my final answer. You try this one, just be careful. Is this even geometric is what I would ask of this. Is it geometric? Is this possible? Okay, is it geometric? Are they multiplying by the same amount every time, or are they adding? So there's your hint right there. Try this one too. Find the sum if possible. So find out what r is. Use your formula to figure it out.